our Gen 1 aircraft will have about 120 mile per hour cruise. Future generation aircraft will have like 240, 250 mile per hour cruise. Like that's like 10x faster than how you can get most places in a car. But it's not just the speed. It's like, if you're thinking, if you want to go to Sedona to like, I actually don't know Sedona where I have been to Phoenix, but I haven't been to Sedona. But like, if you wanted to go from Sedona, like somewhere that's, let's call it like 100 miles away, right? And then you're thinking, okay, like to get there in a car, like it's probably going to be a weekend trip. You have to plan it. There's a lot of friction. But if you can just get up and go 100 miles in, initially it's going to be like an hour, but over time about like half an hour, because now it becomes like, it just becomes like something that's you can do on a whim, and that's spontaneous, right?
Hello, everybody, and welcome to the Founders and Friends podcast. I'm your host, Riley Roseby, joined today with Tsung Xu. Correct? Did I hit the nail on the head?
You got it, man. That's it.
Amazing, amazing. Thank you so much for being here. You are making an eVTOL. You're making flying cars. How does that feel? Yeah. Does it feel real that you are a pioneer paving your way in this new industry?
Yeah, I mean, it's don't really think of myself as a pioneer per se, but like I'm definitely we're trying to do something really hard at Vight, and yeah, so it's going to be a very, very hard journey, but we're just very excited about it because of the vision that we have, and where we think that autonomous flying cars are going to be able to be, and what they're going to unlock for people, and really, like, for a world of human flourishing. I just don't think there is a future of human flourishing without the ability to go point A to point B much, much faster, 5x, 10x faster than we can go today.
So walk me through like the vision of Vight, how that kind of came all together. You and Packy put out a great post. I love how you guys coined the term, expanding your radius. I didn't have the words for that, but I watched a friend of mine buy an airplane. He was his own pilot, and I could see in real time his radius expanding. You guys did a masterful job with that. Like, how does all of that come together? What was the light bulb moment for you of like, I need to pursue something in this space? And then obviously there's a massive gap between the idea of I need to pursue something in this space to actually where you are today. So can you walk us through kind of that first flight path, so to speak?
Yeah. And first of all, Packy McCormick's great, and yeah, he did a great job sort of helping turn my draft into something that was very readable and hopefully engaging for folks. So what started with Vight, and there wasn't really a light bulb moment per se. There were a few moments where I had been working on a software startup and learning to code sort of in the early days of the pandemic after leaving Uber. And I was thinking to myself, like, I don't really want to just work on software forever, right? Like I want to do something that I can be excited for the next 30 years, something that I could turn into my life's work. And, I thought, well, I mean, it's a bit insane, but I thought, look, why, like, I would love to do something that is in hardware and could potentially impact millions of people if it was successful. And for someone that didn't have a hardware engineering background per se, but I had always been somewhat technical, like that was kind of insane. But the couple of moments that sort of helped me get to Vight. One was a few of the eVTOL, or the flying car launches around the time. The Jetson One launch video, and you probably remember that, where very Star Wars Episode 1-esque. Jetson One speeding across the desert, like that had a lot of emotional pull, and it was just really really interesting because I hadn't really been interested in air taxis. I'd looked at that and I was like, okay, I don't think that's the future, and we can talk more about that. I think there's a role there, but I don't think it's going to be like a big application in the way that I think flying cars will be. Um, but the Jetson One video was really interesting. I started to look into the tech, and I was like, wow, the tech stack underneath this, the hardware, the software, the AI, the compute, like everything's just getting so much better. But fundamentally, that type of vehicle, the Jetson One, was really still a toy in the sense that, and I said that in the nicest possible way, because all great technologies have to start as toys, right? Right.
Wilson coined that, where like the next big thing always starts
Yeah.
out as a toy. Yeah. Yeah.
Yeah, it might have been Fred Wilson. Yeah, and I think Chris Dixon might have said something similar. But yeah,
I think you're right.
Chris, yeah, it might have been Chris Dixon. Anyway, but so Jetson was great, but I thought, okay, like, is there a path to make this something that millions of people could potentially one day use and make normal, like just make it boring? Like, how do you make flying cars boring one day? Um, and it turned out that the FAA was looking into the new set of regulations to help enable that. And so the more I looked into these regulations, called MOSAIC, the more excited I became. And so, like, I was started to track that very closely and realize that that was a real regulatory path to get to this future that we're talking about. And then the other thing I started to do around the time was, I said, look, if I want to build a company that's going to build flying cars, I should actually understand the hardware a bit better. And it turns out that you can get a lot of good intuition about building a manned flying robot and flying car from building an unmanned flying robot and starting with drones. So I did a couple of things. I built a autonomous capable quadcopter. So just a drone that could avoid obstacles by detecting how far away it was from things and understanding that through a computer vision pipeline. So some software and some hardware. And then I built a couple of VTOLs from scratch, right? So and I was doing all of this in public, and I had never built anything that flew on a wing at that point. But both of those took about 3 months each. A lot of crashing, a lot of just like debugging, a lot of like working out, just understanding what aerodynamics is, understanding what like how to build structures that were robust, how to um how to do flight testing and refine the controls, and just like just there was so much work that went into that. But then, like, at the end of that, I posted a launch video of my second VTOL. It went pretty viral on X. On internet, it's almost on maybe 90,000 views at this point on YouTube. And so I appreciate that. But but it wasn't so much like the traction and sort of like meeting the additional investors, but it was just really like I really enjoyed it, right? Like, I enjoyed solving these problems. I really enjoyed doing this type of work, and I could really see myself starting a team and starting a company, and like to actually build bigger and eventually manned versions of these VTOLs.
That's amazing, man. I absolutely love it. I have probably a very different background in how I approach this space, but it's so cool to hear your sentiment about wanting to build something in hardware. Because, maybe beginning of this year, I was really feeling this, like, it seems like we're kind of in this interesting place where we're constrained by the hardware we have. Like, software and AI is moving so fast and doing such great things. But until we kind of get to the hardware, it's like this yin and yang relationship between the two that you kind of have to innovate. So that's super cool that you made that jump. And dude, keep going, man. It's been so fun to
I
watch too. Because I think I stumbled upon
appreciate that,
your
man.
Twitter account. I don't know exactly how long ago it was, but it was definitely before Vight. Like, you were just kind of trying things, playing with things, and it was like, who is this guy? Going out there crashing drones, having some fun. So it's encouraging to see. It really is. I'm curious about like structural design. Is that maybe why you're talking about the flying air taxis, kind of these VTOLs that we're seeing, their designs? Is that an area where you're like, this maybe doesn't make sense, or this system is unsustainable the way they have it designed?
Yeah, and I would note that, like, technically, companies like Joby have just done a great job of, you know, first, being pioneers in terms of like this, in their case, a tilt rotor design and that eVTOL design, to a point where, they've done tens of thousands of flights, I think, at this point. And so I don't think the design is flawed per se. I think it's just a very hard path to market, right? Like, and you've been tracking the space for a while. You know how long air taxi companies have been talking about being in market, having vertiports set up, and starting real customer trips. And one of the challenges there is really on the certification side, right? Um, and so the certification, it creates this path dependency where, I like to say, like, certification is destiny, where you are constrained in your design because of what the certification requires. And for Joby and Archer, that meant, having very robust components up and down the tech stack, which are very expensive, take a lot of engineering hours to build and test and qualify. Um, that is just a very different regime to what we operate in because of Mosaic. And we still like will offer a very, very safe flying experience, but that'll be on us to do as opposed to the FAA requiring them to do because of the type of certifications that they're in. So I don't want to like spend too much time sort of talking about certification, but it has put them into a type of design, a size of design, a cost structure that is just very, 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 very risky, and just takes a lot of time to get to market, and you need all your partners and everything.
So are you saying, like, because they're trying to kind of go down the commercial airliner route, like the regulatory that goes into that for them to then get that aircraft to market because that's what they're trying to do, versus for you, is it like kind of the experimental aircraft path to where it's a little bit of a lesser hurdle to clear, and then you're selling it to private individuals so they kind of assume the risk, there's no litigation potential within the company? Is that kind of what you're referring to?
Yeah, I think in broad strokes, but I would just clarify a few things. So yeah, air taxi regulatory path for VTOL, it's not quite commercial airliner. It's they go through a 2117B, like specific type certification that they have to be certified against. It is on the FAA safety spectrum, is much closer to commercial airliners than it is to experimental or ultralights, right? And where a Pivotal or a Jetson would fit. And so the the burden of that regulation is very, very high, and that's why you've sort of seen air taxis spend billions to get to market, because it is very, very high. For us, it's not. We're not. So our cert pathway isn't experimental exactly. It's Mosaic is an expansion of the light sport aircraft category, which was brought in the early 2000s, as a way of innovating in GA, sort of out of the back of like GA really struggling in the 80s and 90s because of litigation and other reasons. So light sport aircraft category became um, a way for the FAA to say, hey, like, within this weight limitation for two-seat aircraft that can fly fixed wing, so conventional takeoff and landing, we want to offer this innovative space sandbox, basically. And then Mosaic was an extension of that, but a very big extension of that, because not only now are you focused on fixed wings, but you also allow for different types of, you could allow for rotorcraft, gyrocopters, in our case, obviously for VTOL. And the certification requirements there are much less burdensome. I can go into that, but basically it just means you can fly in any airspace. You do need a private pilot's license, but we can get people through that in a very, very quick manner compared to how you'd normally have to go through pilot training. And you can fly over congested areas, which you can't do, for example, in an ultralight. And I know you had Heather on your podcast recently. She talked about requiring FAA approval to say fly over an urban area. Like, you don't need that for. You do need to engage with ATC. You do need to engage with controlled airspace, but just like you would in any other general aviation aircraft, like a Cessna or a Cirrus or something.
Yeah. Dude, that is so fascinating. Thank you for going down in the details too, because it's really insightful. How are you thinking about infrastructure? Let's say I want to purchase one of your aircraft when it becomes ready for deliverability. Are you guys helping on the infrastructure side of things? Are you kind of seeing what players in the space do as far as infrastructure? Is that any concern for you guys kind of at this stage, or are you primarily focused on let's get this bird in the air?
Mostly the latter, but there's a couple of things about infrastructure. One of the benefits of focusing on you know, private use and as opposed to having a commercial pilot is that you can pretty much take off and land where people want to. And what does that mean? It means like, for if you have like initially for our first gen aircraft, if you have an acre or so of land or anything above that, you'll be able to take off and land on your property, or have access to that property. You'll be able to take off and land from that. And one thing people don't know about takeoff and landing sites is if you have permission from the landowner to actually land there, you can do so, right? So like helicopters do this all the time. You can go on YouTube and watch helicopter pilots that land next to barbecue restaurants, next to a coffee shop. Like this is actually a thing, right? And obviously you want to make sure that that's safe and the area is cleared off and whatnot. But this is already possible. And so for us, the infrastructure really focuses on people who have initially it could be a grassy small clearing or field. Like one of our engineers actually has that exact thing and on his property, and that's where he plans to take off and land his Vight from. And I mean and all the way through to you could have a helipad that's about 40 foot in diameter, and so some people already have those right on their properties in the US. And but we think that that sort of minimal infrastructure approach initially at first makes the most sense because it's just a very low friction experience, right? It's such that like you don't need to ask a developer to actually go and set up very sophisticated infrastructure operations in urban areas, and you don't need a network of them to be useful, right? Like one of the challenges with air taxis, like you do need, like a network and not just like one route. Like you can have one route, but that one route isn't really going to do much in terms of revenue for the company, and also in terms of and also just in terms of like value for the end customer, right? So I think that's really a challenge where we can pull the demand forward for that infrastructure, starting with where the infrastructure needs are least required.
No, that's super smart, super wise, because it's a tough like chicken and the egg situation, right? Where it's like you need the aircraft up, but then you also need the infrastructure, at least on like the air taxi approach of you need those routes planned and ready to be able to accommodate that. So
Yeah. Yeah, and I'd say one more thing, which is, in the early days of the automobile, right? So Model T launched in 1908, and before that, there were just only a handful of gas stations in the US, and because there was just no demand for a dedicated gas station. You had if you had a Model T or an old a Plymouth or like an Oldsmobile, like a very early car, you would be getting gasoline for that car in a general store most likely, and you would be you would not be like there was no demand for that. But once Model T launched and started to become very successful, it just incentivized landowners and developers to actually put and say, hey, like this is going to be a value add for our land and for our property. Let's develop that infrastructure. Whereas right now there's a lot of push that's required for that infrastructure. And so we want to like have demand pull that infrastructure forward.
No, I love that. I love that. And how are you guys coming at autonomy? Because I feel like when I talk to folks and I'm like, yeah, I'm interested in the flying car space, like the first thing I get back is like, dude, either one, they're pilots and they're like, the airspace is already too crowded, or two, they're not pilots. They don't fly aircraft very often. I mean, maybe for like leisure and recreation or business trips, but they just can't understand and fathom everybody getting up there and flying their own little flying car like what we see in the Jetsons, right? But like, it seems like there's some paths forward. So I'm curious how you guys are looking at that. Are you looking at autonomy at scale as well, or just kind of for the single aircraft?
Yeah, absolutely. I mean, I think autonomy is just critical to um, where autonomy is today, the capabilities of autonomous vehicles today, autonomous tech today, is critical that we're starting at this point in time and not say 5 years or 10 years earlier, right? Um, to answer your points, so uh, i- in the air, like autonomy in the air is in some ways easier to solve than if you're trying to solve it as Tesla or Waymo, right? Like you have kids, you have cyclists, you have motorbikes, you have right, like you have all this, like all of these challenges. And things you have to avoid on the ground. You have to manage complex traffic lights and roundabouts and highways and all sorts of things. Whereas in the air, today like aircraft are very far spaced apart, and like you go into ATC and like you have a lot of time. Well, first of all, it's quite hard to like manually spot an aircraft. Like maybe you've got like the sun in your eyes, or right, like it's like maybe it's cloudy and overcast. Like there are like it can be quite hard, even like flying visual line of sight to spot that aircraft. And so what autonomy does in the air is it just makes that it makes the flying experience much easier. So for a VTOL, um, you know, a lot of people don't know this, but if when you're flying a drone, you're not actually directly flying it, right? Like you're flying it, you're flying a fly-by-wire through a controller, and so like you're giving it intent. You're saying, hey, like throttle up, and then just like, okay, I want the drone to move forward, and the drone flight controller is gonna make the changes to the motor RPM to actually get you to that like position and that change that you want. And so that's the baseline layer. When you add autonomy on top of that, what that means is you can have sensors, whether they be cameras or lidar, where you can like clearly and very quickly see um aircraft that are very far away, like, hundreds of thousands of feet away, or even a mile or more away, and very easily plan a path or trajectory to avoid that aircraft. Like the thing that maybe some people don't think about is, when you're on a highway and you're driving in a multi-lane highway next to other cars, right? Like you have very little time as a human. If a truck or a car swerves into your lane, you have to react immediately, and that's just not the case in almost every situation you'd have in the air, where you have a lot of airspace, like space, little airspace between you and other aircraft, right? So this is something that we don't appreciate. Like you have a lot of time to actually plan what you're going to do, in almost all cases. And so that's point number one. And then to your point about like what happens when there's many, autonomous flying
What
cars out there.
happens when you sell the millionth, Vight, and
Right.
all of a sudden we got traffic jams in the air?
Yeah, which is a great problem to have, by the way, right? And the first point is like that's not going to happen overnight. So there's going to be like there's going to be an iterative approach to solving that problem. It doesn't have to be like planned from day one. But I will say that even in that scenario, right? Like and we've run some numbers on, for example, here in the Bay Area, you have the 101 that sort of connects SF to San Jose, and like through like past Stanford, and some parts of that 101 have on the order of like 250,000 vehicles going through that on any given day. And if you kind of do the math on on how much traffic that would look like in the air if you had that volume of flying cars. It's not that much. It's actually somewhere on the order of 10. You'd have like 10 flying cars per cubic mile. So like imagine a cube that is 1 mile in every direction. Like that's a very big cube, and you could have like 10 flying cars within that cube. Assuming you're using about 2,000 feet of airspace, right? So like if you're using 1,000 feet to or 1,500 feet to 3,500 feet of airspace, like that's a lot of space. And so I think this is something that people kind of don't appreciate, is that one, because on highways, like you're not using much of the land, right? Like you're using a very, very small slice of land to drive on. And so everything feels very packed, right? You're just sitting there next to other cars. But when you're in the air, you have, like not only do you have the third dimension, you also have all this extra space in the second dimension. You also have space over water. You have space over, like you're not constrained to this very narrow sort of like highway in the sky, right? So I think like this is something that folks tend to not think about. And when you run the numbers, it's I think it's going to be very easy to solve well, it's going to be hard to solve, but like I think it's very solvable. There's like the two things on vehicle, like autonomy and intelligence, right, as we sort of talked about, where like you can actually have very, 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 very fast response by the vehicle to aircraft in the immediate vicinity within, let's call it like half a mile, maybe a little bit less, but that's like half a mile or so. So any vehicles that you're going to have instant awareness and how to plan and route around them. And then also eventually like on the ground-based assistance, right? So like ATC that becomes more intelligent. And I know like, the current administration's looking to upgrade ATC, like that. I think those capabilities are going to become very important too. And then the final point I'll mention is that when you're on a highway, you can't just go under a car. Like if a car swerves in front of you, you can't go under that car, right? Like you're very constrained in how you can avoid that car. You can swerve, you can brake, you can maybe accelerate, but that's probably not the best thing to do. And when you're in the air, you have a lot more degrees of freedom in terms of even like emergency maneuvers. And I think that's something that most people don't appreciate. And like supervised autonomous emergency maneuvers, where not the pilot wouldn't necessarily have to initiate or like react to that situation as quickly as the system would.
Well, and I love your point about the time that you have up in the air. Like it isn't this instantaneous slam on your brakes type experience.
Mm-hmm.
I think that's really underappreciated, and I hadn't thought about that. So Tsung, this has been
exactly, because this
has been so fun, man. Thank you.
Yeah, no, it's been fun.
Finish your thought there though.
Yeah, I just wanted to say like it's I call it this like constraint. Like we have all these constraints in humanity's operating system, right? That's how I like to frame it, where we have biological constraints in terms of we need to breathe, we need to eat, we need to drink water, and we need to sleep. Like but sort of in terms of like as a technological constraint, we've always had this governing factor of like how fast we can travel from point A to B, and like cars and road infrastructure, and we've had it for so long in developed countries that we just kind of forget that this is not a hard constraint. This is something that is currently here with our level of technology today. But when you relax that constraint, you think like what's actually possible and what's feasible when we're not driving around on the ground and we're not stuck in traffic, is that like it's just a very different experience that you have to think about, but most people never think about it because right, like it's not part of everyday life. So yeah, it's nice to be able to like have people think differently about things like this and actually question what's possible in the future.
It's really funny you bring that up, because like the light bulb moment for me was I was living in Sedona, Arizona for a while. We have all these roundabouts in town, and it was during like spring break time, so the town was packed. They get 3 million visitors a year, and I was trying to travel like 6 miles, and it took me over an hour, and I could literally like see where it is I wanted to go, and I had to sit there. And they have this airport that goes overhead, and you're looking at all these airplanes. You're like, okay, roundabouts aren't the solution. We need something else.
Right. Right, right. Yeah, that's the thing. Like you can add roads, but you can only add so many roads, right? Because
Look
we
at
need
LA,
space to
man.
live in, we need
Keep
space to
adding a
work in. Look at
lane. It
LA.
doesn't work. It
It
doesn't
doesn't
work.
work, man. It just Jevons paradox. You keep creating you have more induced demand every time you add a lane, and makes it worse. And yeah, like to your point, it's like you look at the horizon, you think, man, that's even without that much traffic, you think, okay, that's maybe half an hour away. Like those hills on the horizon, they're like an hour away or something. But it's a mind warp to think, okay, like what if that's 5 minutes away? Right? Like it completely changes your notion of what is close and near and what is easily accessible. Like it's not just about the speed, and flying cars will be fast. Like our Gen One aircraft will have about 120 mile per hour cruise. Future generation aircraft will have like 240, 250 mile per hour cruise. Like that's like 10x faster than how you can get most places in a car. But it's not just the speed. It's like if you're thinking, if you want to go to Sedona to like, I actually don't know Sedona where I have been to Phoenix, but I haven't been to Sedona. But like, if you wanted to go from Sedona, like somewhere that's, let's call it like 100 miles away, right? And then you're thinking, okay, like to get there in a car, like it's probably going to be a weekend trip. You have to plan it. There's a lot of friction. But if you can just get up and go 100 miles in, initially it's going to be like an hour, but over time about like half an hour. What does that change? Like, because now it just becomes like um something that's you can do on a whim and that's spontaneous, right? And I think people forget that, like, you lower that friction and all of a sudden you can just have all these different experiences. You can think about living in different places. You can start thinking about working in different places in a way that we just haven't had to think about for a long time because cars haven't gotten any faster on our roads in
Yeah.
100 years.
No, dude, I absolutely love that. I mean, I had a friend up here earlier this week. I texted him, "Hey, you want to grab lunch this week? Like, let me know what your plans look like." He's like, "Pretty slammed, but we could do breakfast down in Crested Butte." And so Crested Butte from me, where I'm currently at, is about 2.5 hours driving on mountain roads. So you don't always know what you're going to get. There could be some traffic and accident. I think we took off maybe around 6:30, 7 o'clock. I got back here to my desk by 10:30.
Yeah, wow.
Going down new place.
For breakfast. Yeah.
It was fantastic. I do want to touch on Sedona just briefly. I know they're having an air show coming up in October, and I did get pretty friendly with the general manager over there. So if that's any interest of you and Vight going out and doing a showcase, I'd love to introduce you guys. I think you would like to see the scenery because it looks like Mars. So it's one of those things where it's like, it looks like you're kind of living in the future out there, like you were talking about with the Jetson One, like that emotional pull. It really hits home to that. So
yeah, appreciate that. Yeah, we can definitely chat afterwards about that, and yeah,
your team is expanding though, right? I noticed on your website you guys are hiring some positions. So if folks are interested in this, what's the best way to kind of reach out to you, learn more about the space? I mean, I'm telling my friends almost every day, like, you got to just get interested in what's happening in aviation. Like personally, I don't care where in aviation, but there's so much moving forward in this industry that like you just got to kind of start playing, connecting with people, putting feelers out there. So what's the best way for folks to find you and to learn more about Vight?
Yeah, so best way, in terms of those roles I mentioned on the website, so vightaero.com. And yeah, you can apply directly. That'll come straight to me. And you can also email me, tsung at vightaero.com. And yeah, and just if you're interested in any of those roles, always happy to chat to very strong engineers who are very, very excited about building this future with us.
Dude, that's amazing. That's amazing. Oh my goodness. I wish I could be a fly on your wall at some point in time here, man. Truly.
Yeah. You have to come down to Mountain View sometime and check out the shops.
I might. I just might. I would absolutely love it. The area is beautiful out there, and I don't know. I'm just so excited that technology is finally kind of moving in that direction where we're pushing the needle again in hardware and solving real problems, right? Like, to me, kind of that Web 2.0 era, I don't know your full history, but like if you worked for one of the big tech companies, you may have been solving problems, but we're seeing now you're actually creating a lot of new problems. And we're going to create new problems with eVTOLs and flying cars and all these things, and we're going to mitigate, handle that. But it really seems like we're in this shift, and I'm so grateful to have connected with you because, dude, you are a pioneer. You're pushing the edge of innovation, so it's amazing to watch.
I appreciate that, man. Yeah, no, I wasn't at, well, I was at Uber for a couple of years, but I wasn't at like Google or Meta or anything like that. So yeah, I never found, and even Uber, like, thing I like more about Uber was it was like real world, like it was solving problems in the real world, right? Like it
Rewarding.
wasn't just, right, and it wasn't just like selling ads, and so like I was never really into that, and so yeah, so for sure, like I mean hardware is, and just building in the physical world, physical AI, robotics, like I think we're just very early in, I mean it's a very very huge um change, and that's just an exciting change, and I think a lot of the messaging from like AI labs around the impact of AI has scared a lot of people, but um I think there's just going to be a lot of benefit for everyday folks, right? Like, you know, and for us, you know, it's just going to enable a whole, you know, 100x, 1,000x more people to become pilots, and fly aircraft, because the system is going to be the first arbiter of like safety, and making sure that you know, like you have an enjoyable flight, and a safe flight. And you know, the pilot, you can still engage as a pilot, but it just does so much um for you, and even from day one, as an aid, and then over time, like we're going to engage with the FAA, and get to that world of fully autonomous flying cars, and robo taxis, where you'll be able to just hail one, right, for personal use. And so I think that's a really exciting future, and you know, so that's what we want to build.
I'm thrilled to see you building it. Truly, anytime you want to come on here and talk about whatever it is you guys are up to, it's always an open door. And dude, let's make flying cars real.
Let's make them real. Appreciate it, Riley. Yeah, it's been fun to come on.